That's it. Acting Director, Captain Liu, distinguished guests, and of course, colleagues. Thank you very much for giving me the opportunity to present to you my first presentation, which is on runway safety with a focus on stabilized approach criteria. When I put this together, I realized this is a very complex topic. It's a mammoth in scope and size. So I put together a presentation which is designed to go for 3 hours. And Alex said, "Great, you have 25 minutes." So forgive me if I speak quickly and breeze through some of the slides in order to get us out of here at a reasonable time today. Let's first start by talking about our industry. Last year was the most successful year in terms of safety we have ever had in the history of aviation. Last year, the accident rate fell to 2.1 accidents per million departures worldwide. That's unimaginable. Now, if we take away the turboprop operations, because that's higher risk, but we also don't deal with that very much out here. We take away the death traps that are made in Russia, and we take away the Sky Cowboys that are flying in Africa and northern Canada. We're left with an accident rate somewhere around 1 accident per million departures. This is literally a 1 in a million type of event. And just to prove that the Asia-Pacific region is not the ugly stepchild of the rest of the industry that nobody wants to talk about, I put the red line there to show you that the Asia-Pacific region consistently outperforms the worldwide average. Last year, our accident rate was 1.8 per million departures. That's derived from 19 accidents in the region. Asia-Pacific was responsible for almost 31% of global traffic, but only 25% of the accidents. So turn to somebody you know, as my colleague would say, and say, "Congratulations, you are an ultra-safe operator." No? Okay, I tried. You should pat yourselves on the back, because this is thanks in large part to the expertise of everybody in this room as well as countless others. But we can't pat ourselves on the back for too long, because there are other issues that we have to deal with. The first of 3 is control flight into terrain, loss of control in flight, and runway safety. And that's the big one that I'm here to talk to you about today. Over the last few years, runway safety, which covers everything from excursions to veer-offs to incursions, has been going up. You can see on the slide compared to virtually every other category. Last year, the excursion rate increased by 60% over the 2015 global average. So this is starting to become alarming. The Flight Safety Foundation did a study and found that unstable approaches were factors in 66% of the 76 landing accidents that they were looking at. So what does it look like? This is what it looks like from inside the airplane.
Here we are in Morocco. Bye-bye.
Now let me ask you a question. As a passenger, when did you realize something wasn't right there? What was that? Right off the bat, wasn't it? Because the captain said, "Cabin crew be seated for landing." And what were they at? 300 feet? You could hear the panic in the cabin crew's voice as she's cutting out things from her PA. Her voice is saying, please be seated for landing, and her internal voice is saying, what the heck is going on here? So that was an Airfield Express A320 that was departing from Manila to Kalibo. That's the aerodrome they use for tourists going to Boracay. There were 142 passengers and crew on board. Fortunately, nobody was injured. The aircraft came to a rest at a grassy portion of the stopway 56 meters, so that's about less than 200 feet from the end of runway 23. The estimated speed at touchdown was 156 knots, which is fast even for a wide-body 777. They touched down at 4,600 feet down the runway, and the runway is 7,175 feet long. So the quick math tells us we have 2,575 feet left to stop. The primary causal factor of the accident was a failure of the flight crew to discontinue the approach, even though prevailing conditions suggested that would be the prudent action to take. The contributing factor was the decision of the flight crew to take runway 23 when it was offered to them a runway change, only 4 miles before landing. Now, you may say to yourself, these types of events don't happen that often. We're not hearing about this. Nobody's ringing any alarm bells. But it's happening all the time. In fact, at this airport alone, in the last 4 years, had 5 runway excursions. Now, my wife is a former journalist of 15 years. She used to say to me, if it bleeds, it leads, which is a very morbid way of saying if there's blood and guts and bodies involved, it makes international news. But if nobody's killed, or nobody's seriously hurt, at best you'll make the local news. So alarm bells haven't been rung. But the reality is, people are getting injured, people are getting killed, and these types of events are costing our industry billions of dollars in damage to aircraft, damage to property, injuries, and yes, even deaths. So how do we proceed? What I'm proposing is a systems-based perspective. We need to look at it holistically with all the different components. I'll touch on that in a second. We need to utilize risk management tools with our solutions, which means that we're going to address not only the probability of these events happening, but the severity when they do. Now, if ALPA, Hong Kong ALPA, we tend to get a reputation as pilots as being a zero risk type of people. But the reality actually isn't true. Because we're dealing with risk management, we need to address this in a way that focuses on ALARP, as low as reasonably possible when we're dealing with this risk. We recognize that there is a trade-off between protection and production. If you focus too much on protection, then you end up with a bankruptcy. If you end up too focused on production, you could end up with a disaster. So the systems-based perspective. I'm sure as air traffic controllers and pilots, you've been familiar with untimely events, unfortunate events, possibly even accidents that you're familiar with. And if you look how people address these types of events, you'll see that whether it's the regulator, the SMS, the corporate safety systems, they tend to want to get to the bottom of this. They're looking for what Dr. Sidney Dekker called the root cause. But he also called it the root cause seduction. Because what he says is people tend to try and tease back to find the exact component or the exact culprit responsible for this failure of our system. So they start looking. They first focus on the mechanical side. And if there's nothing wrong with the mechanical, they look at the processes and the procedures, the policies that are in place. And if there's no failure there, then by default, they go to the human component. And sometimes that's where they leave it. So they either retrain the pilot, or in some cases, remove the pilot. And that makes us feel better. It makes us think that our system is safer because we've taken that bad component out. The trouble is we operate in a complex system, which means, in one word, emergence. And what emergence means is that the behavior of the system is not defined by the individual properties or components, but rather it emerges as a collection of the parts. So what we need to be looking at is not just the pilots or the air traffic controllers in isolation. We need to look at the relationships between our components. We need to look at the interdependencies, managing conflicting goals, dealing with variable performance and unruly technology. And sometimes we are the unruly technology. So today we're going to be talking about pilots, but we're also going to be talking about aircraft operators, aircraft manufacturers, airports, regulators, and yes, air traffic controllers. But I'm not going to talk about primary causes. I'm not going to point fingers. I'm not going to blame anybody. In fact, I'm going to get arrogant enough to say, I'm going to tell you how to fix the problem. But I'm counting on you to tell us how we implement these solutions. So here we go. The Flight Safety Foundation determined that 65% of accidents happen on the landing phase. They also determined in their study that 85% of excursions could have been avoided with a simple decision to go around. So if you do the math there, what this is saying is we could eliminate 54% of all accidents worldwide if we just went around. That slide, by the way, is a study of all the runway excursions they were looking at. The red ones are the jet aircraft, the blue ones are the turboprop. So that's where they ended up, and our runway is sort of right there in the middle. So the question we have to ask ourselves for the pilots, and this is open to you during the question and discussion period, is why? Before we get into why they don't go around, we actually need to figure out why they got unstabilized in the first place. What are the issues? Is it fatigue? Is it stress? Is it the workload? Did somebody lose their situational awareness? Or is this part of normal operations? Is this just a regular outcome? Or are there external factors? Something tied in with the system? I'll leave that to you. Without looking at your notes, what percentage of unstable approaches worldwide do you think go around from an unstable approach? I'll give you a hint. It's gone up since the last time I saw it. The actual number is 3%. 3% of aircraft will go around from an unstable approach. Why? We also have to answer that question. Did they get lucky from previous experience? Was there an ego involved? Did they not understand the risks? We need to figure these things out. What are we talking about when it comes to stabilized approach? This is what pilots refer to as a stabilized approach. It is an industry best practice, and it basically works like this. No matter where we are in time and space, we need to end up at 1,000 feet at a certain point in time with a certain amount of energy. So at 1,000 feet, we're roughly 3.15 nautical miles from the threshold of the runway. That gives us 75 seconds until touchdown if we're grounding speed of 150 knots. Some carriers will use 500 feet in VMC conditions, but I don't believe that's used by any of our carriers in Hong Kong. So what we need to be is stabilized vertically, laterally, horizontally in that plane. We need to be fully configured with our gear fully deployed, our flaps, speed taken into consideration prevailing conditions, which also include air traffic control speed requirements. So that means you can be going a certain speed at 4 miles and be slowing back to your normal speed. That's acceptable. But it also means we're happy to give you 180 knots to 8 miles, but we can't give you 180 knots to 4 miles because we can't slow down enough in time. All briefings, PAs, and the landing checklist must be complete. And this is important. This is not just a gate for us to pass through. The aircraft must be stabilized from this point on throughout the rest of the approach. So typically in the industry, your speed has to be maintained within a tolerance of VREF, the speed you'd cross the threshold at, to REF plus 15 knots. Descent rate can't be above about 1,000 feet except for momentary excursions. And thrust should be set according to what you would expect under those prevailing conditions. That's what stabilized approach is all about. Now, when something bad happens, inevitably, and an unstable approach comes about and somebody has to answer for it, this is typically what they envision from a office to the from a visit to the local office.
Now, Captain, I'll ask you a simple question. Will you stabilize at 1,000 feet according to our standards?
Yeah.
Okay. So another question. Is it reasonable to penalize pilots for unstable approaches? It's a very important question to ask, and I realize that opens up a whole Pandora's box. The reality is, some aircraft operators and even some regulators, though not this one, sir, do penalize, even criminalize errors. And I see this as I get to, in my role at FALPA, I get to attend numerous conferences at ICAO. And I watch these regulators stand proudly and tell the entire platform that they have the safest industry, the safest nation in the industry. And so I'm inevitably asking the question, how do you know? And then they tell me, well, it's simple. We get almost no reports whatsoever. And then my heart sinks, and I realize I have to tell them that you don't have a safe system. What you have is no reporting culture. And then their face drops, and it's like telling my kid that there's no Santa Claus. So the pilot component, what are we concerned with here? Pilots need to have a stabilized approach criteria to work through. They need to comply with their SOPs, but they need to feel that they're able to make these mistakes and account for them where necessary. They need to do a landing performance on every single landing. Now, that doesn't mean that they have to actually do a calculation. It means they have to do an assessment of their landing distance. They need to nominate an exit point. Why? Because the exit point is actually the action point. These are the top 3 things that Boeing and Airbus agreed on that will virtually eliminate runway excursions. They need to know their aircraft performance. And by that, I don't just mean normal operations, but they need to be able to answer the questions like, how much longer is my landing going to be if I cross 20 feet higher? How much longer is my landing going to be if my reverser fails? And they need to have improved monitoring and assertiveness from the pilot monitoring. These are important things. Studies looked at why this doesn't happen, because some of these investigations show that pilot monitorings almost never call unstable approach at the stabilized approach gate. Why? So things they've explored, they're unsure what to say. They believe that a safe landing can still be made. They believe that it's the captain's or the pilot flying's call. Or perhaps they become task saturated. They don't know what's actually happening. What else? Air traffic control. Here's where it gets a little hot. How do our roles conflict? In a lot of ways, pilots don't fully understand the role that the air traffic controller plays. I hear this all the time when pilots on their PAs will blame air traffic control for delays in advance before we get into Hong Kong. The reality is that the only thing stopping from pilots getting exactly what they want on any given day is the weather and other aircraft. So if your buddy wasn't there, you'd get exactly what you wanted. But sometimes we do have conflicts, and we're going to talk about that hopefully during the breakout session. Shortcuts and vectors. Shortcuts are great. They're great when you're departing, they're great when you're in cruise, and they're even great in approach under certain conditions. We have to make sure that we don't lead the pilots into a false sense of, we got this under control. You could lead a perfectly capable captain down a path he doesn't actually want to go on. And my son last night said, could you please tell the air traffic controllers to stop routing you around, rerouting you after holding? My son is 8 years old and he's not a pilot. But I think he's been watching that flight radar a little bit too much. But he has a point. Why are we vectoring aircraft when we have beautiful SIDS and stars? Now those could be improved, but could we do more with speed management? And the reason I'm asking this question is because pilots configure their aircraft based on track miles. If we don't know how many miles to land, we don't know where we need to be in the sky. Late runway changes. This almost never happens here, but it happens at a lot of other places. It happened at Kalibo there. Sometimes it'll take us to do a good job 5 to 10 minutes to prepare and plan for an approach on any given runway. If you change that at the last minute, it doesn't mean that we can't do it, but the risk goes up. Now, this is an interesting one I want to show you. I want to thank Cathay Pacific for the release of their flight data on this. This is flight data animation from an unidentified aircraft from years and years ago. This is a 747. It was operating passengers, even though it says cargo on the side. That's the software. And it was coming in from a long-range operation, and it was being radar vectored with 400 passengers on board. It's being radar vectored just inside east of Tonic. Now, where would an aircraft typically be at in terms of altitude crossing Tonic? Give me a number. Anybody? 3.5? Maybe? That'd probably be a little bit high. But yeah, I'll go with 3.5. We're at 6,200 feet. So take a look at the altitude. We'd be crossing at what, 180 knots? We're approaching 200 knots. So if you haven't seen animation before, you're going to be tempted to look at the aircraft, but don't. There's not much to see there. What I want you to look at is the settings. The speed, the heading, the altitude are all there. The modes are a little bit off because of the software. Command here shows that the autopilot's in. And I want you to watch the flaps, because he needs to get flaps 30 out for landing, and the gear will come down here. Normally at about 2,500, 2,000 feet, it'll come out at 4,300 feet on this one, because he needs to expedite the descent. And as I start to roll it, where's my pointer? As we start to roll and move, you'll see the pointers for the localizer and glide slope start to come in. So Cathay XYZ, turn right, heading 040, cleared ILS 07 left. Report established. I think your PC is starting to hang up a little bit. IT. I think that's probably as good as we're going to get, but have a look at the rate of descent that this pilot is having to do right now, 1,800 feet, which at 5,000 feet is not a problem yet. Yeah, you can try fast forwarding a bit, but not too far. That's fine. Okay, so we're now on final approach. We're established on the localizer, but the glide slope is well below the pilot's altitude. We're now at 2,700 feet, and we're doing 2,500 feet per minute rate of descent. So we're looking at impact in about 1 minute. Any of our pilots spot the next problem this captain's going to have? He's got an issue with speed. He's still doing 200 knots. He's still got flaps 20. And he's about to capture his 2,000 feet. I don't want to fast forward it too much because this is where it all starts to happen. Okay. Maybe just give me a little bit more. Okay, so he leveled off, realized he had caught his altitude, so he's dialed in 1,000 feet now. He still isn't established on the glide slope. He's still at flaps 20, and he's only just started reducing his speed. forward then. So we're through 1,000 feet now. At 1,000 feet, remember what our stabilized approach criteria was? On speed, fully configured. We're still at flaps 20. We're at ref speed plus about 40 knots. And he was doing a rate of descent of 2,000 feet per minute as we crossed 1,000 feet. 30 seconds to impact.
Go forward a little bit.
Yeah, go for it. Now he's got flap 30 out. He's just caught his glide slope. And we're back on speed. What altitude was he stabilized at? You don't, do you? Giving him 5 seconds to read the checklist, I would call him stabilized at 300 feet. Now he touches down, and it's at that moment when the speed brakes come up and the reverse is set to idle that a wave of emotions will be crashing over this captain. I don't know who it was, don't care. But I can tell you exactly what he's thinking. What the hell just happened? And then he's going to start to feel guilt and shame, or he may not have even realized what happened. That does happen too. Now, of course, the big question is, why didn't the pilot go around? But there's another question to ask. How did he get in that position to begin with? Well, there were two sets of shortcuts given to this crew. The second one you saw was the turn inside tonic, but the first one was actually a 30 nautical mile track shortening on his arrival. Now we descend at roughly at a 3-to-1 ratio. So that means for 30 miles, we've essentially cut off 9,000 feet from his profile. What happened? Now again, we're not blaming anybody here, but we have to ask, is there a better way to do this? Of course, we have to look at the aircraft operators as well. Do you have a go-around culture at your airline? And I'm not talking about one that's in print in the manuals. I'm talking about a real go-around culture, because there is a difference between what you write in your manuals and what happens on the line. Are there conflicts with your fuel efficiency programs, on-time performance? I've even heard of cases around the world where a pilot goes around and is handed a bill for the fuel. Is there even a stabilized approach criteria established? And do you train for go-arounds, not at minimums, but at a variety of different altitudes? Regulators. Starting to get warm again. We need to have approaches on every runway that commercial operations use. According to a study by Airbus, if you have a runway without vertical guidance, you are 30 times more likely to have an accident on that runway. If you take away lateral and vertical guidance, it's 50 times more likely. We've got RNP now. What is stopping us from doing this? We need oversight. We need training. We need culture. We need regulation. And when things go wrong, we need investigations. We need to be held accountable. Aircraft manufacturers. Airbus and Boeing have designed some great systems, but they've also provided us with some great guidance. This is a great video I recommend every pilot have a watch of. It is done by Boeing, but it is not aircraft specific. It's called No Landing is Routine. And it talks about the need to use all the aircraft systems for braking performance. The other thing that Airbus and Boeing have been doing is improvements in technology. Airbus has their runway overrun protection systems. Boeing has the runway situational awareness tool. What this does is it looks at the aircraft's energy state in real time, all the way down to the landing rollout, and determines, based on the aircraft's known braking performance, whether or not it can make a stop in the allotted runway. This is the tool that actually set off go-around in Dubai when Emirates went around and unfortunately crashed, but that had nothing to do with the runway protection system that was offered there. One of the new devices that's coming out is aircraft as a sensor, which means the aircraft will sense its own deceleration rates compared to its movement with GPS and give you a braking report based on ICAO that you can then pass to other aircraft. These are amazing tools that can really help our industry. But here's the problem. It's only a useful tool if you have it. And so we say to Boeing and Airbus, if you're going to charge more for these options, be prepared for the airline operators not to buy them if they don't see the safety benefit from it. Airports. Local runway safety teams. Proper maintenance of all the runways. Improved measuring and reporting of runway conditions. I know the airport is working hard on this. I also have to ask the question, are all of our runway taxi and crossing points protected? Even in Hong Kong, do we have red stop bars on all taxiways where these runway incursions could occur? These are important questions. Runway end safety areas or EMAS protection. And effective communication to stakeholders. Here's what I mean by that. There was a recent incident a few months ago where a Chinese mainland carrier had a taxiway runway veer off on the side. It was during very heavy rains, and the aircraft essentially slipped off because it hydroplaned. Now, the solution to this from the airport was to put out a notice that said, caution, runway slippery when wet. Now, what do you think the airport was trying to say to pilots? Please take care. Watch out. The trouble is that the terminology they used was actually ICAO standard, and it means that the runway friction due to rubber contamination exceeds the ICAO threshold. So what it meant to the airport was be careful when you're turning off. But here's what it meant to the pilots. When a runway is wet, we still have good braking action. But when a runway is slippery when wet, which means anytime it rains, we have medium braking action. And that affects us because instantly, overnight, when that NOTAM came out, we went from a crosswind performance for takeoff from 38 knots to 20 knots. Now, all of a sudden, no pilot can take off in the rain in Hong Kong in 21 knots. Nobody knows why. Line ops is going crazy. But it all came down to communication breakdown. One of the things FALPA is a huge proponent of is runway end safety areas. We believe that the 240 meters that ICAO currently uses as a recommended practice needs to be upgraded to a standard. And here's why. According to the ICAO Aerodrome Design Manual, 83% of runway overruns could be contained within a runway end safety area of just 240 meters. If you can't do a runway end safety area, there's a substitute available. You can use EMAS, which is Engineered Materials Arrestor System. Things like this can save lives, and they reduce the damage to the aircraft. It makes a huge difference, so that this doesn't become this. This is Chicago Midway, where a 737 exited the runway, crashing into the street and killed a 6-year-old boy. We still have events like this happening because we haven't fixed the problem yet. Just 9 days ago, SpiceJet had an aircraft run off the runway in Mumbai. 183 people were safe, but of course there was significant delays and damage to the aircraft. And I kid you not, I was looking on LinkedIn the very next day, just going through, and I saw this. We're looking for captains. No assessments. What that's saying is we don't care if you're good or not. We just want you to come and fly our airplanes. Ladies and gentlemen, success and failure come from the same source. They come from ordinary work. And so if we're going to fix this system, we need to design a system that is resilient, that is robust, that can tolerate bends, flexes, and even failure of individual components without the system crashing. Nothing that I've said here is my own opinion. It all came from these sources, which you can find in your notes. And I'm sorry for running over time, but if there is any time, I can take any questions or comments. Nothing? Thank you.
Can you just stay? I would like to pose one question to Brian. He's talking about shortcuts in the terminal area, and some of these are okay. But obviously, when we deal with, say, Cathay 777, a 777's not a 777. It can be regional flight, can be long haul. So if a controller has to go through a number of these assessments of when is an appropriate time to shortcut, could you elaborate on what you mean by sometimes it's okay?
Well, that is a very poignant question. It's very difficult, we accept, for controllers to decide when it is or is not okay because of the range of weights and speeds. What I'm talking about is more looking at profile. Is this aircraft in a profile that is consistent with what you'd expect to see from other aircraft at that time? Now, there can be speed differences, of course, but if you see an aircraft that's 4,000 feet above profile, or even with looking at the turn inbound from tonic, even just 1,000 feet, it's probably not a good idea to give them a shortcut. But that said, this is a dual responsibility, because it should also be up to the pilot then to say, no, I can't accept that shortcut. I need these extra track miles because we're high on profile. So if we change this paradigm so that it's a shared responsibility, I think that's a solution that we can work towards.
It's just one other as well. On, say, the aircraft on base leg in your capture there. Mm-hmm. At what point do you think a controller should have some duty of care of perhaps intervening? And I mean, generally a controller will go through a process. Are you able to, you know, so many miles from touchdown, are you able to get in? At what point do you think, we're always taught that it's pilot and command, we have to defer to you, but at what point do you think it would be appropriate that we would perhaps level the aircraft off and simply reposition it?
Ooh. That sounds more like a technical question for your ATC experts, but I would suggest the solution actually lies in not getting yourself in the situation to begin with. As the captain, for example, when we're coming in from Sierra and we're looking at a tight turn in, I much prefer it if the air traffic controller says, Cathay XYZ, when able, turn left, proceed direct to Limes. And that's giving me the prerogative. It's also saying that I know that you know that I know that you're not quite there yet. And so it sort of is communicating without actively communicating about that. At the end of the day, there is a duty of care here. And I think at the point where the controller feels that this would be an unsafe landing, and as I said, I don't have the expertise of looking on your screens and knowing exactly what that looks like. I think when the controller gets alarmed, the first thing he should do is ask the crew, are you okay? Do you need any extra track miles? Anytime that becomes an alarming issue. And that at least voices out that there's a problem. And if all else fails and you can see the aircraft is still descending at 2,000 feet a minute inside 1,000 feet, then yes, I would welcome an intervention as saying, Cathay XYZ, go around. But I think that's a situation that it has so many different variables and combinations, it's impossible to pin it down to a definitive gate such as the one we have for stabilized approach. We have to share that responsibility, if you will.
Xavier.
Sorry about that. Brian, thank you very much for your presentation. Really well done. I think it highlights a lot of points for a lot of us, I think, in the industry. Just, if you don't mind, just in regards to Mike's question and, you know, when is it acceptable, when is it not acceptable? I know Peter, we've talked about in the past. Thank you, Peter. And Mike, we've talked about on this subject before. Just for you, Brian, I was involved with some of the changes we made to the approach through Murray. I was involved to lower the level down to 1000. And again, thanks to all the people from air traffic control to working together and combining to make a better approach. I think a lot of the issues we find, and what I try and drive with our crew, is very much that, you know, once you get a Tango Delta at 1000, once you get a Murray at 1000, okay, the modes used by the pilots when they get that next descent, a lot of time dictates how they're going to go with that approach. And we know, like in your presentation, the issue was not really the unstable approach. The issue was always what mode they would have used after Tango Delta or Murray. Why did they not lose their height and then lose their speed? Peter and I have talked about this on previous occasions. I know Mark wasn't too happy at the time, but it was very much, you know, get the guys down earlier. Okay, if you get them down earlier, then they can control the rest. Where some people look at their profile, which is what you mentioned, and they go, oh yeah, I've got enough track miles to go. But this is Hong Kong, and somebody like Mike or any controller, he knows he might have a gap and he wants to try and close it in. Now I know Peter's talked about it, you know, trying to give us, you know, guava, instead of making it 8,000, bring it down a bit to about, you know, 7,000 or 6,000 feet. These sort of solutions that can bring the aircraft down, okay, yes, it's not perfectly on profile, but any sort of track shortening or anything like this that come into play to assist the controllers would then make a big difference, and you would get rid of a lot of this. You know, what I try and teach our guys, once you get a descent out of Tango Delta Murray, you just, in Airbus term, you go open descent, you just get down. You lose your height, get down to 6,000 feet, whatever the height you've got, and then after that you VS it. That gives you the opportunity then to control your speed a lot better than, you know, and you lose your speed. Now, the other thing is, I think, you know, I got taught by one of my previous instructors, and, you know, he's ex-Cathay, and he gave me the gates. Lime's 4.5, tonic 3.5, and I know you say it's a bit high, but at our speeds, if you're at the right height, you're exactly on glide slope for us. And it works really well. I've used it for 12 years, and the only issues I've had has been associated with a typhoon. You know, you got bad weather, hey, I'm sorry, going around. But I think there's a lot of these sort of things that the pilots, in regards to profile management, have got to be careful. And it's not about maintaining your height after Tango Delta Murray, it's getting down. Once we do that, we can help air traffic control so much more. But again, thank you for your presentation.
Thanks, Brian.